So students, let's come back and do one more numerical which is based on your empirical formula. So here till now what do we do? They've given us the data. I've written a tabular column. From that you've got your empirical formula. Now we'll be calculating molecular formula also from empirical formula. Right, let's read. What did they give us? What is the simplest formula of the compound which has the following percentage composition? Okay, they've given us two elements. One element is carbon, the other element is hydrogen. Percentage composition is given to us. Fine. And if the molecular mass is 30, calculate its molecular formula. Okay, that is what I need to do. So first of all, your step 1 should be calculation of empirical formula. Step 2 should be calculation of molecular formula. Let's start. First of all, let us make a tabular column. As I said, always first important thing, find out empirical formula, then go to the molecular formula. Let us write that. First finding out empirical formula, then finding out molecular formula. Fine. So in the first thing, always this first column will have the name of the element or the symbol of the element. So what did they give us? So this will be element. What is the element? Carbon. Right? I've written the symbol here. Next element is hydrogen. Fine. So in the first column after this, of the element name, you will have percentage composition. As I've explained in the earlier numerical, how much is carbon? 80%. How much is hydrogen? 20%. Now after this, immediately you will be writing the atomic mass of both. Right. So for carbon, atomic number 6, mass number 12. For hydrogen, 1 is a mass number. This is over. After this, you are going to take relative ratio or relative you are comparing both the things, relative ratio of number of moles. So relative ratio of the number of moles, how much do I get? I am going to divide 80 by 12 in this case. Here I am going to divide 20 by there is no number, it's only 1. So here when I divide, I get an answer of 6.66. Here in this case I get 20. Now I need to find the simplest ratio. Right? In the simplest ratio, as I have told, you are going to see which is the minimum value. Here in both the cases, this is the minimum value. So you are going to divide by 6.66 divided by 6.66 in this case. In this case again, 20 divided by 6.66. Fine. So I'm going to get, when I solve the 6.66, how much do you get? This is 1, isn't it? And when I divide this, you get 3. Now simplest whole number ratio. So if you're not getting whole number here, you need to further do the simplest whole number ratio. But here already I have got simplest whole number 1 and 3. Now what is the formula? For carbon, the formula is C1. Now this is empirical formula. What is? This is C1. How much is hydrogen? It is H3. Done. So no need of writing 1 here because it doesn't make any value. CH3 is the empirical formula. Underline this. Please write it in full form. I'm not written. Now I need to find the molecular formula. So molecular formula, what is the formula? Molecular formula is equal to empirical formula into N. This is the formula. Now what is N? N is nothing but, if I have to write, N is nothing but the molecular mass by empirical formula mass. Okay, right. This is your third one. Okay, right. Let us take this as 1. Let's take this as 2. Let us take this as 3. One after the other we'll do. So what is molecular mass given? How much is N given? Molecular mass is 30 given. What is empirical formula mass? What do? You're going to take this empirical formula, calculate its mass. How much? Carbon mass is 12 into 1. Plus, how much is hydrogen? It is 3, isn't it? 3 into 1. When I take this, how much do I get? I am going to get 15 as a weight. Done. So this is the empirical. Once again, carbon mass number is 12 into 1 plus hydrogen mass number is 3. Number of hydrogen atoms is 3 into 1. So total 15. So I've got this part, isn't it? Molecular mass 30. I'm calculating this one. After calculating this one, I'm going to substitute in this. So 30 divided by 15, I get an answer of 2. Now I've got N value. It varies with every numerical, isn't it? Now take that N, substitute in this. So this is your friend. Now I'm going to calculate molecular formula. That is, how much is empirical formula? I got CH3 into 2. This is 2. That means carbon will become, the molecular formula finally is, carbon is C2. Hydrogen is 3 2s are 6. That's it. This is how we are going to calculate. So finally, what did we got? We have got two things. First thing is empirical formula. I got it as CH3. Molecular formula, I have got it as C2H6. So you're going to write in this way, and just this is the maximum they will ask you. Let us see any other type of numerical which are related to this. Right, let us come back and do one more type of numerical in your empirical formula. So basically, what is this? Let us read the question first. So hope till now you would have understood. I need to calculate first always empirical formula, then I need to go to the molecular formula, isn't it? Yes. So here they've given us butyric acid contains carbon, hydrogen and oxygen elements. That's understood, right? And they said they've given some data. What is this? A 4.24 milligram sample of butyric acid is completely burnt in oxygen. Okay, combustion reaction happened, it seems. Then what happen? It gives 8.45 milligrams of carbon dioxide, 3.46 milligrams of water, right? What is its mass percentage? Okay, they've given us about carbon dioxide, they've given us about regarding water, but here what is the problem? They've not given us oxygen separately, because here I need to find the formula for carbon, hydrogen and oxygen, but here oxygen is combined, here also oxygen is combined. I need to find that particular mass, right? Then what is the mass percentage of each of the element? Right, determine the empirical formula and molecular formula of butyric acid. Molecular mass of butyric acid is given to us. Fine. So when I have to do such numericals, first of all, find out or take the common thing, that is the basic thing, basic data of oxygen, or sorry, of carbon dioxide, of water. From that extract out oxygen and then start solving the numerical. So for the first thing, when I have to solve the numerical, yes, yeah. Let's see. First of all, I need to calculate from like for carbon dioxide. Let's see. So in carbon dioxide, if I have to speak, first of all, let us calculate the weight of carbon. Why am I taking that? Because I need individual carbon. Yes. So what is this? 44 grams of carbon dioxide or milligrams of carbon dioxide contains how much? Okay, let us write mg. Okay, milligrams of carbon dioxide contain 12 grams of carbon. 8.45 milligrams contains how much of carbon? Then I'm going to cross multiply with this. 8.45 into 12 by 44, which comes to 2.30 grams. This is over. Now I need to calculate the percentage. Why? Because this 8.45 gram, but the total is 4.25 grams. The sample is 4.25 grams, milligrams. In that 8.45 was so much. So I need to find the percentage, isn't it? So I'm going to find percentage of carbon, right? So how much is that? 2.30 by 4.24 into 100. Then I've got a percentage. How much did I get? 54.24. Okay, I've got 54.24 percentage of carbon. Now let us find the same for hydrogen. So in terms of water, when I have to take, yes, water, what is the molecular weight? 18 grams. Okay, 18 milligrams rather, contains how many hydrogen, how much weight of hydrogen? 2 grams, isn't it? Now 3.46 grams, 3.46 milligrams contains how much of hydrogen? You need to find that first. For that, you're going to cross multiply in this way. 3.46 into 2 by 18. Then how much do you get? You get an answer of 0.384. Now I need to find the same percentage of hydrogen. Same percentage of hydrogen, right? Now see, 0.384, total is 4.24. Find the percentage. 0.384 divided by 4.24 into 100. How much do I get? I get almost 9.05. Because why did I get less? Because there's still oxygen present. I need to find. Now this is your carbon percentage. This is your hydrogen percentage. Now I'll find for oxygen. So percentage of oxygen. Or how do I do? Take the total 100 minus 54.2 minus of 9.05. Then when I do this, I get 36.4 percentage of oxygen, right? So finally I've got three compositions. One is carbon is 54.24, hydrogen 9.05, then your oxygen 36.4 percentage. Now with this data, I need to calculate the molecular formula. Finally, before that, I need to calculate the empirical formula. Let's come back and do that. Now let's come back and do next type of numerical. That is, here the concept of vapor density is given. The same concept. We need to find the empirical formula, molecular formula, but only thing is vapor density is given. So what is given? An organic compound on analysis gave the following data. In that organic compound itself, carbon percentage is 57.82%. Hydrogen is 3.6 and the rest is oxygen. Fine. So let us start. Let us write the given data. Let us write step 1. So in step 1, my aim is to first calculate empirical formula. From here, I'll go to molecular formula. So let us write the step 1. Let us make a tabular column, very vague line. I'm sorry for that. Yes. So in the first step, what will I write? I'll note the elements. First, carbon. What is the percentage of carbon? 57.82. Next, hydrogen, 3.6%. And oxygen is rest. That means 57.82 plus 3.6. That total minus 100. How much do I get? I get 35.8%. This is over. After this, I'm going to write the atomic masses of all. So atomic mass is equal to, for carbon it is 12. For hydrogen it is 1. For oxygen it is 16. Now I need to find the relative ratio for getting the number of moles. You're going to divide this by this, you're going to divide this by this, you're going to divide this by this. When you divide the first case, 57.82 by 12, how much do you get? You get 4.818. In the second case, 3.6 divided by 1, 3.6 only. In the third case, 35.8 divided by 16, you get answer of 2.40. Now I'm going to find what the simplest ratio. Simplest ratio. For the simplest ratio, I'm going to see which is the minimum value. This is 2.40 is the minimum value. Now divide 4. Okay, let us take out this line. I need some more place. 4.818 divided the minimum value 2.40. The second case, 3.6 by 2.40. In the third case, 2.40 by 2.40. I'm trying to get a simple whole number ratio. That's it. So when I divide this, what I'm going to get? Here in this case, 2. In the second one, 5. 1.5. In the third case, 1. Okay. Still, I have not got the simplest whole number ratio because this is 1.5, isn't it? Fine. Now, simplest whole number ratio. So to make it simplest whole number ratio, just see with which number if I multiply, I get a simplest whole number ratio, isn't it? Suppose if I multiply everything with 2, let's see, this also 2, this also 2. Yes, let us start with 2. Suppose if I multiply with 2, this becomes 2 2s are 4, simplest whole number ratio. 1.5 into 2, 3. Simplest whole number ratio. 1.1 into 2, this is 2, simplest whole number ratio. So I've got 4, 3, 2. This is the simplest whole number ratio. Now I've come to a conclusion of empirical formula. So what is empirical formula? So carbon is equal to C4, hydrogen is equal to H3, oxygen is equal to 2. This is your empirical formula. Now I need to calculate what? Molecular formula. So molecular formula, what is this? Molecular formula is equal to empirical formula into N. What is N? I said N is nothing but molecular mass by empirical formula mass. Is any molecular mass given to us? No. Here they've given us vapor density. Fine. So once again, one more formula. Molecular mass is equal to 2 into vapor density. This is the formula. Fine. So now see. 2 into 83. How much do I get? I get 166. Isn't it? So this part is over. Molar mass, I got 166. Let us keep this aside. Later we will write. Let us find first. So molar mass I've got 166. Now let us find empirical formula mass from here because I want that data. So hope you would understood this. I have linked vapor density with the molar mass. I got this answer. So if I have to see 4 into 12 plus 3 into 1 plus 2 into 16. When I solve this, I get an answer of 83U. Now take this, divide, because empirical formula mass I got it here, molecular mass I got it here. So 83. So how much? It goes twice. Now I got almost done with the numerical. The final step is I need to find the molecular formula. This is N, no? Nothing but N. So what is molecular formula? Empirical formula into N. How much did I get? I got C4. C4H3O2 into 2. What do I get? I get 4 into 2, 8. 3 into 2, 6. 2 2s are 4. So this is your molecular formula. So now I've got two formulas. What is that? First one, empirical formula is equal to C4H3O2. Molecular formula is equal to C8H6O4. This is your answer. This is how you're going to find. Right, let's come back and see the last type of method of calculating empirical formula. Fine, let us read. So pure sample of a compound is found to contain 2.04 grams of sodium. Okay, a sample has contained 2.04 grams of sodium in that itself. Right. Next component is 2.65 into 10 raised to power 22 atoms of carbon. Very interesting. They have combined everything and given to us. And 0.132 mole of oxygen atoms. So mole is given, they've given us atoms, they've given us weight. Determine the empirical formula of the compound. Right. So first of all, when such compound, some question is given to you, to find empirical formula, you need to have the percentage. That is one thing. Okay, they've given it in a different way. Atomic masses, you know, fine, and you need to finally get the whole number ratio. Then only you can frame an empirical formula. So let's see how can we do this. First of all, in this particular numerical, the method for doing or calculating empirical formula is calculate the number of moles or the number of gram atoms for in each case. So first of all, for calculating number of moles, okay, for sodium, I'm getting first for sodium. What is sodium? That nothing but your weight by gram atomic weight, isn't it? How much is this weight? 2.04 divided by 23. Gram atomic weight of sodium is 23. The atomic mass rather. When I solve this, I get an answer of 0.0887. This is for sodium. Now I've got the number of moles because I need to find out the whole number ratio. Next comes your carbon. When I have to take carbon, what is given? They've given us 2.65 into 10 raised to 22 atoms. But we very well know 1 gram atom of carbon contains how much? It contains 6.022 into 10 raised to 23 atoms or particles, isn't it? Yes, so here atoms is given, this is also atoms. Both should be similar. When I cancel this, I get an answer of 0.044. This is for carbon. This is over. Yes. Now next is oxygen. Oxygen directly they've given us mole, not a problem. Here I've got moles of this, here I've got moles of this. Here oxygen directly they've given moles, that is 0.132 moles. This is done. Yes, now I'm coming almost closer to now I can easily find the ratio. So when I have to find the simplest ratio, see which is minimum. Which is a minimum value? 0.04 is a minimum value. Now divide. 0.0887 divided by, okay, you can also take the ratio first of all. Let us see. Is to 0.044 is to 113. Now for us, finding the simplest whole number ratio. Now this is simplest ratio. I need to find simplest whole number ratio. Then divide with the minimum value. In this case, this is the minimum value. So 0.0887 divided by 0.044 is to 0.044 divided by 0.044 because it's a minimum value is to this one 0.132 divided by 0.044. That's over. When I cancel this, I get 2 is 2. Here 1. Here when I cancel, I get 3. Now over, isn't it? I have come to a formula. Now apply. What is the first element? Sodium. So sodium, what did I get? Na2. Second element is what? Carbon, C. Third element is what? Oxygen, CO3. So this is your formula. We have already got from that ratio, from that number of moles in atoms that I have calculated, I have got this. The final empirical formula is Na2CO3, that is sodium carbonate. Now we've got the percentages. Let us start calculating the empirical formula and molecular formula. So let us write this as step 2. So in step 2, what should you do? First, let us try to make a tabular column. Fine. So in this tabular column, okay, I need a bigger column. Yeah. So in the first one, the first column is always what? Elements. What are the elements given? Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Now after this, the second step would be the percentages which you have got, which you have calculated already in step 1. First one, carbon is 54.24. Hydrogen is 9.05. Your oxygen is 36.4. Done. Immediately, as soon as you write the mass percentages, you need to write the atomic masses of all. So in this case, carbon atomic mass is always 12 grams. Hydrogen 1. Oxygen atomic mass 16. Yes, done. Now I need to find the relative ratio of number of moles. Okay, right? Why did I write this? Because weight by molecular weight, isn't it? That is nothing but number of moles. Fine. So when I divide this by this, how much do I get? I'm going to get an answer of, okay, let me write 54.24 divided by 12. I get an answer of 4.52. Done. Fine. In the second case, 9.05 divided by 1, it is only 9.05. In the third case, 36.4 divided by 16, I get an answer of 2.29. Right. Fine. Now I need to find what? Simplest ratio. For finding the simplest ratio, what is the rule? You need to see whichever is the minimum value, so which is divisible. So take this value, so 4.52. Here minimum value is 2.29, so you're going to write 2.29. Here 9.05, you 2.29. In this case, 2.29 by 2.1, just to get a simplest ratio. I'm trying to simplify the ratio. Simplify it so that I get a simplest whole number ratio finally. So when I divide this, I get an answer of 1.97. Here when I divide the second one, I'm going to get an answer of 3.95. In the third case, I'm going to, okay, nothing, 1. Now finally, I need to write simplest whole number ratio. Here all are in decimals. I need to make it in whole numbers. So 1.9 I can write it as 2. 3.9 I can write it as 4. 1 is like that. Now I can now make empirical formula. What is empirical formula? Carbon is 2, C2. Hydrogen is 4, H4. Oxygen is only 1, O. So nothing to write. This is over. Fine. So now immediately, as soon as you get empirical formula, try to calculate the empirical formula mass and keep it ready. Fine. So immediately empirical formula mass. So how much is this? 12 into 2. Mass into this plus, you can write it like this also, 4 into 1. Oxygen is 16. Total how many? 44 atomic mass units, grams. Fine. Gram per mole rather, if I have to say. Done. I've got this answer. Now come back. I have to find out what they've asked me to find out empirical formula. I did that. Then they've asked me to calculate molecular formula. So molecular formula is equal to empirical formula into N. But what is N? N is nothing but molecular mass by empirical formula mass. What is molecular mass given? 88U. So 88 divided by your 44. So how much do I get? I get 2. Okay, let us erase this. Okay, I have not got my duster today. I just kept. Okay, 2 I have got. So how much is this? N. Now substitute this N in this. Why am I doing that? Because I need to find the molecular formula. Yes. So molecular formula, when I do, what is here? Empirical formula is how much? C2H4O into 2. Now multiply, this becomes C4. Hydrogen becomes H8. Oxygen becomes 2. So this is your molecular formula. So I have got both. Now empirical formula which I got is C2H4O. Done. Second molecular formula which I got is C4H8O2. This is the thing. So this is your first answer. This is your second answer. This is how you're going to do.